What I want people to get from this talk is first, Exchange and Office APIs and the way how to work with it is changing. Graph APIs, my goal is to show how simple it is to use it. It is really simple. It's amazingly simple. When I first started looking at Graph API, I was just amazed by the way how quickly you can start and produce code that actually does very complex things. And today I'm going to do presentation on two topics which seems to be quite separated, but they're still all about Exchange in different forms. My name is Andrew Davidov. I am a senior software engineer in the office, and my areas of responsibility are mostly around open specifications, protocols, as well as Office extendability. And in this first part, I'm going to introduce Graph APIs, just general overview, how they work in general. So how to use it? You start with registering your applications to get client ID and redirect URI. And this is all well documented, but I'm just highlighting the steps. Then you use OAuth for authentication. Using this client ID and redirect URI, you get access token and use it in each request. You just supply it with a header, as one of the headers. Now you then call resource URIs with one of typical HTML operations. And what's important is that all calls in Graph APIs follow the same basic URL pattern. What's in it? This is endpoint, obviously. Then you specify API version, a resource that you want to access, and then you do OData query parameters. OData query parameters can be quite complex, but I'm not going to talk about this. If you have questions, we have OData experts here as well. So in this URL, version is target service version, either 1.0 or beta. Depending on what you specify here, you have different features available for you. Resource is basically what you want to see, what you want to access, users, groups, devices, organizations. There is special alias me. Once you authenticate it, me means everything that I have in Office 365. So you can access resources using this me events, me drive, me messages, and so on. This special alias my organization, I'm not going to talk about it, just mention that it exists. And then query parameters. There's great documentation about this on graph.microsoft.io. So sample application, and large part of my presentation is going to be demo of that. It's available on GitHub. Please use it. If you like it or want to add something, please do so. It has sample code for two platforms, for Android and for Windows. What's important that I want to stress is that it is a real-life application. It is something that really works with calendar, and it is something that's actually meaningful. In addition to that, we implemented quite extensive logging, especially in Windows application. And I'm going to use this logging to show what's going on the background, what calls are happening, what's happening on the wire when calls are done. Another interesting feature of this sample is that we don't use SDK in any SDK in any form. Everything that is done directly through HTTP. So you can use this as an example how to implement things. And if you can do HTTP, you can use this. So what you will see there, first, calendar operations. Calendar can be queried in two ways. You can query events, or you can query calendar view. The difference is important for recurrent meeting, for series. Like series have just one event, maybe more with exceptions. But if you use that, you will need to do expansion yourself, which is extremely difficult to do. So server will do it for you if you ask for calendar view. You just ask, give me calendar view from this time to this time. And you will get any event that shows up in calendar during this time. If you want to take a look at recurrent meeting, like on recurrence pattern, or if you want to create, you work with events. And you can, so you can get calendar view. You can get event directly using event ID, which you can get you can get from calendar view. And for event invitations, there is interesting functionality that allow you to access, deny, and some magic is happening on background for you. Application that works with calendar and obviously needs to work with address books and contacts. It needs to work with users. So Office 365 has two kinds of users. You can access and query users from address book, global address list, basically directory, or you can query contacts. They're coming from contacts in your mailbox. And I have example of what's going on there. For contacts, you can actually get a photo. For email used in this sample, I will show you how to do reply or forward. And here's what's going to happen on the background. The application is going to search for meeting message. If it finds it, it will open it, let you update it, and then send it. And it happens in 4 calls. And if everything goes right, I will have a chance to show you how it works. Okay, I'm going to demonstrate C# version. And this version has very extensive logging implemented. With this logging, I show how authentication works. I show how tokens are being exchanged and the magic behind this. And then how to work with calendar item, what is special about that. How to work with contacts, how to work with email, send, receive, and actually add stuff in the calendar. So this is our sample application. I press connect to Office 365. I'll press this button. I will explain later what it's doing. So now we are in this interesting screen. This part of it is displayed by Office 365. It is not application part. In fact, application doesn't even have access to this data. So when I type this, actually, sorry, this one, or both of them. This one, when I type password, application doesn't have access to this data. And that's an important part of OAuth principles, that the application doesn't have credentials of the user, it has tokens that allow it to access certain part of the data with very fine granularity. Okay, a lot of interesting things happened. And we have a view of my calendar today. I'm using my test account that we use with Pui and Michael. Let's take a look at what was happening. I have this log window. So first, you see navigated to logonmicrosoftonline.com. This is where this screen is coming from, as a frame. From that call, we received authorization code. Again, we just get authorization code. What account? Don't know. And the response, we get authorization code. It's not code that we can use for access, but that's the first step of it. That is here, right? And then we use this, sorry. Here we use this authorization code to call login Microsoft Online again. And you can see that next call is graph.microsoft.com. Totally different endpoints. So let's see what we get back from second call. we get several interesting things. This is scope, what rights I have. I can read calendars, I can read, write calendars, access contacts, read, write. Mail can read, write, and send as user. Send as user is interesting, special scope. People are usually not willing to grant full access, so in some cases, application can get can request just give me read rights, but not send as. And this is sort of assurance for administrators or users that strange stuff will not happen. We got 3 tokens. First one is access token. This is the token I'm going to use now. This application is going to use now. This is EYJ0EX. This token expires, usually expires in an hour. When it expires, the application will need to use refresh token to get new one. And the refresh token, it lasts for about 2 weeks. And ID token is just another way to explain who the user behind is. I'm not going to use it. We're not using it at all in this sample, but there should be documentation on that as well. Let me close this. So now when we have this access token, we can make a call. And this is URL for Office 365. First call to Graph APIs. We use version 1.0 and want to know who I am, what is me. And you see we use this access token here. This access token actually points to user and all the rights. So you don't specify in calls, you don't specify who user is. And you can know who he is, but it's not needed for calls. Okay. Response. This is JSON for response, and this is what is me. Interesting thing is that in headers I also have some diagnostic information, including what data center I hit and how long it took, stuff like this. And last call that happened, calendar view. The application is showing view for today, all meetings for today. But just in case we're asking for meetings for yesterday and tomorrow as well. It's done just to make sure that we don't miss something. There is some interesting side effects when you move from time zone to time zone. Meaning of all day changes, so it needs to be handled if you care about it. But anyway, let's take a look at response. We have a bunch of meetings. Extend 2016, that's today. And what you're getting back is a lot of data that you can use to display, make decisions. And I want to point out how easy it is to get this data. It's just relatively simple calls, and you get a lot of information that allow you to build the view of your calendar or operate on your calendar. Now let's go back, and I will show you what's happening when we work with contacts and users. I open new meeting. Let's subject say location. I can find room. Then let's add attendees. You can add user from directory, or you can add users from contacts. And in contacts, we see slightly different view. There's slightly different information supplied for every contact. And let's take a look what was actually happening. So here's my first call to get users, and I was asking for just 10 users. But I can, in response, I know that if I get all or not. So I can page through chunks of users of this data. And this is a list of users that are available from Active Directory. Next call I made was go to contacts. First I'm asking for contacts count, and here's list of users. Different information, more information for each sorry, it's not users, contacts. More information for each one. And two of them show that they have photo available. So the application asked for photo. We don't have way to display, it's just in the body, to display photo in the log. Let me cancel this, and let's just do a couple users. I will put Michael. Okay. And let me show you filtering. Okay, so what was happening? This is, here I ask for all users, you already seen what's going on. And here is filtered call with just for filter for given name, principal name, or starts with. And here in response, I should get just one. Yep. Okay, let me create this appointment and send it. So here it shows up. Now I have Pui's mail inbox open here. And I already received message from him. So let me open it. And before I press accept, I want to show you what I'm showing here for this meeting. It says no response, right? Now I'm going to this one. I'm going to accept. Okay, let's go back to Meeting Manager and hope that this mailbox received this request. Open it. And you see Pui accepted. What happened on background is that in the calendar view for the view, this meeting will show up as accepted by Pui and no response from Michael. Yeah. So Pui accepted and Michael, no response yet. Another thing is how to accept or decline meeting invitation. I already have meeting that Pui sent me, but I didn't think I accidentally replied to it. So let me go to Puyo's mailbox and I will just send it. Let's go to like Friday. And I'll create invite to me. Let's send anyway. Now I have this meeting on my mail. So the service is working really quickly. It's really happening. The mail was being delivered. And here I have options: accept, decline, tentative. So let me accept, edit response. So what was happening is that we sent accept, like we do post saying we need to accept this meeting request. And what's in this post is actually comment and send response to. And finally, responding to the meeting request, I do reply all. Okay. And in this case, let's see in Puyo's mailbox. We need to wait until it will arrive, but let's see how actually yeah. Here's what was going on the background. We searched for the meeting, get the meeting body, then we created draft. It was just we created draft, create reply all. We patched the draft with our content. You see, and then we sent it with a post. Second part of my talk is open specifications. This documentation is very special. It describes how Microsoft products work over the wire. It is not API, we are not talking about API, we are talking about what's really happening on the wire. And I'm going to talk about the three protocol families of Exchange. What is called MIPI, Exchange Web Services, and Exchange ActiveSync. So open specifications, very different kind of documentation. It's not talking about APIs at all. Documentation is talking about what's happening on the wire. It's strictly normative, and normative part doesn't have even mention Microsoft. For Exchange, there is good overview document, which I suggest to use if you want to use Exchange protocols. It highlights three important protocol families. There are three important protocol families. In red, there is MIPI, what belongs to MIPI. The first one is call for the data. This is address book data. And this is commonly used across all protocols in MIPI. There is web services and ActiveSync. So again, three important protocol family, RPC ropes, that's what is behind MAPI, including NSPI, web services, and ActiveSync. And there are other groups of protocols as well. I'm not covering them in this talk in details. Here's how it works in storage side. There's one single storage on Exchange server, and you can access it through different protocols. For MAPI, we have now we have MAPI HTTP, which is a way to access the same data without using RPC transport. But important thing here, what I want to stress, is that it doesn't matter through which protocol you're coming, you're getting to the same data. And ActiveSync and web services actually can work with complex data on the server side. Complex data like meetings, tasks, attachments, and so on. For MAPI, a client is responsible for a lot of work to make those objects consistent. So first, RPC ropes, protocols behind MAPI, implemented a long time ago from day one, and they're very complex. Here's what complexity means. RPC is used, and I'm giving this as an example of RPC. It's roughly the same with HTTP, just that this is just transport. Can be RPC, can be HTTP. So RPC has binary blob. RPC call transmits binary blobs, that's it. In this binary blob, we have several ropes, remote operations, packed together. And what's difficult about that is that we have rope size pointing to server object table, handle table. But rope itself, they don't have end markers at all. It has rope ID and rope data, that's it. So you need to be, the application that is working with this kind of protocol needs to be able to parse all ropes that it encounters. And today we have 130 ropes documented. We have web services. This is a way to access the same data in more streamlined form. And it has advanced versioning. Transport is SOAP over HTTP. We have ActiveSync, which is lightweight synchronization protocol. And optimized to work over high latency. It's just specifically designed to work for mobile world. Transport is WBXML over HTTPS. And as I said, mobile phone, tablets, and some desktop applications are using it as well. Not all changed features are accessible through this. Version history. What's new in Exchange 2016 we have? I think most interesting is support for drafts folder. It's amazing that we didn't have support for drafts folder before. And those protocols are, each of them have different purpose. Like MAPI is what Outlook is using for very extensive and rich data. EWS provides rich data as well, and in fact, Outlook for Mac is using EWS. And ActiveSync is like protocol of choice for mobile devices. But now we know that more and more mail applications are starting to use Graph APIs for mobile world. So we have support in interoperability tools. And as I mentioned, there are other Exchange protocols that I'm listing. You will have access to this presentation. So for test tools, we have updates. We use message analyzers to create parsers, and now we started using Fiddler as well. So we have Fiddler inspection for MAPI HTTP. And we produce test suites. Test suite is implementation based on protocol. We read the document. We do implementation based on what's there, code it in C#, and run it against a real server, Microsoft implementation. And it should work. If it doesn't work, then documentation doesn't match the release. Finally, we have ask you to provide feedback. This is an important part of our release conditions. And Exchange and Outlook support standards. We support IMAP, POP3, and 3 standards in iCalendar or in RFCs. Today we have feedback period open for 90 days. Please, if you have some feedback, please provide. Talk to us now, or there is email stand@microsoft.com. This is information how to reach us. But we are really listening. This defines what will happen in the next releases. And I'm listing resources. Okay. What I really want people to take home from this presentation is you can access very complex data in a very simple way compared to what we used to have. You can work with this data using just HTTP calls. It doesn't matter what language you use. As long as you can do HTTP, you can access this data. This is new. This is really something new for Office 365. We don't have this on-prem, at least not yet. And I want people to be convinced that this is the way to go.